Hi guys, so we have an O-level past paper question from the year 2017. The session is May-June. This is question number 8. In this question, we'll use trigonometry and scale drawings to find different lengths, angles and areas. So let's start. In the question, they've given us a triangle and a trapezium. The question reads, ABCDE is the cross section of a building. All lengths are given in meters. Calculate DC. They've asked us to find this length over here. Now, if I extend a horizontal line from B all the way to ED like this, one second, let me draw a line like this. This line would be the same as DC. So let's call this point X. The reason why I draw that is because I want to find the length of XB, which is easier to find because I have this length over here and I also have this length over here, XE. How do I have this length? So I subtract 4 and 6 to find this, which is 2. So now I have a triangle, a right angle triangle, which has a length of 2, 15.1 and XB, which is the unknown. I use the Pythagoras Theorem to find it. So I do 15.1 whole square minus 2 square, which is equal to XB square. So I can even write XB first. When I do 15.1 whole square minus 2 square, I get 15.1 whole square minus 2 square. I get 224.01. Then I find the square root on both sides to find the length. So when I find the square root, I end up with 15 meters. So if XB is 15 meters, DC is also 15 meters. I write it over here, 15. The next part says calculate angle EAB. That means they've asked us to find this angle right here. So we have this length, we have this length, and we have this length. The easiest way to do this is use the cosine rule. So what I write is, I write 15.1 whole square equal to 9 square plus 11 square minus 2 times 9 times 11 times cos EAB, because that is what we are looking for. Now I can even write cos EAB on one side and I write the rest of the stuff on the other side. So I take 15.1, I keep it on the left and I take everything on the left. So I get minus 9 square and minus 11 square at the top, and at the bottom I get negative 2 times 9 times 11. Okay, so when I plug this into the calculator, let's find what we get. I do 15.1 squared minus 9 squared minus 11 squared. This is being divided by negative 2 times 9 times 11. I end up with negative 0.13136. When I do cos inverse of this, I'll find the angle EAB, which comes out to be 97.6 degrees. 97.5 degrees. 97.5 degrees. So I write it over here. Okay. The next part says calculate the area of the cross section. That means we have to find the area of this part and this part. We can do that individually and add them up. So let's first find the area of AEB. How do we find that? We use this angle, which is 97.6, and we use the sine formula for the area. So area of triangle EAB can be found by using half times 9, which is one of the lengths, times the other length, which is 11, times sine, which is the angle in the middle, which is 97.5. So you do 97.5 and we find the area, which comes out to be, let's see, 0.5 times 9 times 11 times sine 97.5. This comes out to be 49.07 meters square. Okay, we have the area of the triangle. Let's find the area of the trapezium now. So the trapezium is BCDE. So area of trapezium BCDE. How do you find that? We multiply half by its length, which is 15, which is the length that we just found. This is the 15th. This length is 15, and this is being multiplied by the sum of parallel sides. Now the parallel sides in this are 4 and 6. So you add them up. You do 6 plus 4. Okay, let's plug this into the calculator. So we do 0.5 times 15 times the sum of parallel sides, which is 10, and we get 75 meters square. Okay, so the total area would be when you add 75 and 49.07, you'll get the total area. So let's do that. 49.07 added to this gives us 124.07 meters square. So you write it over here, 124.07 meters square. Okay. The last part of the question says, a model of the building is made using the scale 1:50. What is the area of the cross section of the model? Give your answer in square centimeters. So the scale that we have is 1 centimeter is to 50 centimeters. But the area that we have in the previous part we got was in meters squared. So first let's convert this scale into centimeters and meters. So this 1 centimeter would be equal to 0.5 centimeter. But be mindful that this scale that we have is a scale for the lengths. If we need a scale for the areas, we need to square both these values. So the scale for area would mean that we square 1 and we square 0.5 as well. So when we do that, we get 1, of course 1 square is 1, is to 0.25. That's the meter square of this thing, and this is centimeters squared. Okay, so if 1 centimeter square is equal to 0.25 meters square, and the area that we just found was 124.07 meters square, this is equal to what? So we cross multiply this. I'll do it over here. So x meter square is equal to 124.07 times 1 divided by 0.25. X comes out to be, let's see what we get, 124.01 divided by 0.25 gives us 496.4. 496.4 centimeter square. So you write it over here, 496.4, and we're done. I hope the question made sense. The complete working of the entire question is present in the description below for you to download. If you like this video, hit the subscribe button, and thank you so much for watching.